In this video, we're going to go over the while statement. So for this, again, we're going to open a new file in Graphical Robot C. And while the if and if else statement makes a choice, it evaluates that choice when it gets to the program and then it moves on. The while statement, otherwise referred to as a while loop, will continually operate whatever code is inside here until it is no longer satisfied. So that's why it's called a while loop instead of just being a choice. So whatever you put in here is something that would repeat. So in the previous video, we used the if and else statement to stop the robot when it got too close to a wall. And we can achieve that same action here using a while loop. Because something I didn't mention is since an if-else statement, it just checks it once and then moves on, that entire program would need to have a loop in and of itself, so it is at some point constantly rechecking that if statement. Because without it, it would just run through the code once and stop. So when you're doing something that is very specific or something that needs to be repeated, and that's the focus of whatever is occurring in the program at that moment in time, a while loop would be most appropriate. The one thing with a while loop that you can't do, like if it's driving around and you want to stop, since it's stuck in this loop, it's not going to be checking other things or basically acknowledging any code that's outside the while loop. So it is very focused in that it's only focusing on that one part of the program while that condition is being met. So if we want to have our robot drive until it gets close to a wall, we can do that same thing. So our while loop, we can come down, we can choose our sonar. So now we want it to loop while the statement's true. With all the logical expressions, it always executes what's inside when the statement in the parentheses at the top here is true. So in the if statement, we had it stop when it was less than 150 centimeters. In this case, we have to word it from the opposite perspective. We want the robot to continue moving while it is greater than 150 centimeters. So last time we used the less than symbol. This time we're going to use the greater than symbol. So effectively, we're doing the same thing. We're just approaching it from the opposite frame of reference. Instead of stopping it when we get less than a threshold, we're having it move while it's greater than that threshold. The threshold hasn't changed. It's still 150, just like in the previous video, but we're just changing the perspective that we're looking at it from. So while our robot is further than 150 centimeters away from the wall, that means it has space, it's clear to move, so we will have it set our multiple motors. We'd have right motor and left motor. So while this is true, it's going to keep making sure our motors are supplied power. So it's going to continually move. When this is not true, it exits the loop and then moves on to the next code. So since we want it to stop when this code is no longer true, we simply put our stop all motors command after. So while this is true, it's going to continue moving, keep moving, keep moving, keep moving. Eventually, when this number drops below 150, we exit the loop and we then come up to the command where we stop it. So we can add in our comment, continually drives while path is clear. So it continually drives while the path is clear, and then when it exits, it stops if an obstacle is encountered. So instead of having an if-else statement with, if one If it's clear, it moves, or else it stops. We're using a loop. Another circumstance where we can use a while loop is if you are opening the claw or moving the arm up and down, since that is something that you wanted to do probably before you then move on. So like if you're trying to grip something with the claw, you want to make sure that claw is fully closed before you then move on to the next portion and have the robot try to lift it or move it or something. So for instance, if you want to move the arm motor, what we have is, sorry, we have an encoder on the arm motor. Sorry, not the encoder. We have the potentiometer on the arm motor. And we can check that value. So if, while our potentiometer is less than a certain value, so the potentiometer, remember, only measures 180 degrees. So that scales in the potentiometer from 0 to about 4,500. So while the potentiometer is less than 4,200, so like for instance, while the arm is fully down or less than fully up, since it, from the bottom it starts at 0 and then it moves its way up until it hits a certain value. So while it's less than that value, if for instance, we'd be lifting the arm here, we can have that arm motor move. So we'd select arm motor, it moves at whatever speed we want to move at, and then again, after it gets to the position we want it to, it exits the while loop and stops all of the motors, and then we can move on to the next task. So this while loop lifts the arm up approximately 180 degrees and then stops it. So for instance, together, this entire code would have the robot driving around until it encounters an obstacle, and then it would lift its arm up as written. Because remember, we'd loop in the one while loop until this condition is no longer satisfied. We'd move out of it, stop all the motors. We'd enter this while loop, assuming that the arm is down to begin with. It'll lift that arm until this is no longer satisfied, and then move on to the next point and stop it, and then you'd have your next thing. So you're not making decisions with while loops. You are performing a set repeating operation until a condition is no longer met. So that's why you can use these in conjunction. You can use if-else statements and while loops together. While loops are used for repeatable actions that need to occur that is tied to like a specific value. So if you're trying to open the claw to a certain amount of open, or you're trying to clamp down onto something of a certain size, you can use the while loop until that's satisfied. If you're trying to lift the arm up to a certain position, you can use the while loop and change this value, 4,200. If you only want to lift it up halfway, you just would scale that in half. So half of 4,200 would be 2,100. So now the arm is only lifting halfway up instead of all the way up. You can change these values again depending on what kind of clearance you have, what kind of object you're trying to pick up, how much you need to pick it up by. Because since the arm is, reaching out to something that is not underneath it, when it's depending on how heavy that object is, it can be harder for the arm to lift it up, and then it gets more complicated for the robot to move depending on where that object does. Because as it lifts up an object, it's affecting the center of mass of the robot as a whole, and then that changes how it's controlled ever so slightly. So you have to think about, like, if you're trying to start or stop, you have these extra forces that you have to deal with. And then that goes back to the physics that we talked about at the beginning of the year. Again, we are not going to have to calculate any physics at this point. We're not dealing with anything that substantial or something that needs to be that fine-tuned, but that is going forward how you kind of tie all these things together, from the physical design and making sure it's being controlled in a controlled and proper manner. So you get, again, the desired outputs instead of just kind of having it fling things around. If it's moving something that's not as heavy as it expects, or then not having enough power in the motor to lift what you want it to lift up. So those are things you always need to be aware of to make sure that you are using the proper tools to um, accomplish the proper tasks. So I hope you guys now have a better understanding on what the while loop does, its purpose, and how you guys can use it to achieve some kind of output with the robot. So there should be a assignment where you're going to create a very brief program using the while loop to get some kind of desired output.